So this is what this. If you type link command, you will get this. As I said a week ago, this is just an experiment, whether it makes sense to just choose homework problems a week earlier. And if this works out, I will eventually create a channel on my Discord server. By the way, join the Discord server. Yeah, the link should be available now. Do you know what is Raif round on Codeforces? I don't know. When you Google Raif, like R-A-I-F in Google, only Raiffeisen Bank pops up. I don't know if it's that. I'm not aware of any Raif programming company. So many Indians watch him. Yes, that's true, because half of Codeforces users are from India. I don't know Leetcode statistics, but should be the same. Yeah, after this problem, we will move to the one we started a week ago, and I solved it for k equal to 2. But first will be this. You need to create a matrix with non-negative integers, such that you know what should be the sum of every row, what should be the size of the sum of every column. For example, here the input is that sums of rows should be 5, 7, 10, sums of columns 8, 6, 8. For example, here the first row is 0 plus 5 plus 0, that's indeed 5. Then it should be 7 and 10. Maybe somebody from the chat, Twitch, anybody wants to describe the solution? Perfectly, maybe this should be with a voice chat. I might also experiment with this in the future. It wouldn't be voice chat available for everybody, just kind of trusted Discord server users or something like that. Or I can also create some Patreon and get $1 for everybody who wants to get access. Okay, just take meaning of row and column. Let's investigate this idea. Was the homework discussion on Saturday? No. Saturday are Codeforces, and this previous and next Saturday we just discuss solutions from Codeforces round. Let's investigate this idea. Take minimum of rows and columns, or take minimum of row of I and col of j. What? I'm now thinking if I understand the problem correctly. But if I correctly understand exactly this idea, then for 5, 7, 10, row sums is this, col sums is 8, 6, 8. And you need to create a matrix of size 3 by 3. If for every cell you try to decide about a number and you put here 5, this already seems very dangerous. This is 5 because I know that the sum here is 5, the sum here is 7, the sum here is 10. And also we know sums of columns 8, 6, 8. That's a nice way to do this. If we really use this idea, take the minimum, then, well, what do we have from this? If we put 5 here, then the remaining sum in this column is 3. And maybe that's some kind of issue. But let's see. If this is 5, this is 3, and this is 0, I'm here typing what's the remaining sum. Or maybe let's copy paste this. and like this will be a backup. Yeah, the remaining sum is decreased, and now if we take a look at any number like this one, well, I cannot put anything here, then just 0. What about this one? 0. What about this one? 3 and 7. I need 3 in this column, 7 in this row, then 3. So this strategy is about choosing as big number as we can in every cell in some order. But what order do we need? We'll see. The remaining sum here is 4. It was 7, but I already put a 3. So I need 4 more. What about this cell, the middle one? I need 6 in this column, 4 in this row. Put 4, the minimum. And these are the remaining values. And this should be, we should be able to already from this guess if there is a solution. And the solution is that in this column I need 2, in this column I need 8, and this row is 0. So we have defined values. In the last row it must be 0 to 8. And indeed it satisfies everything. But why is that? Is this a coincidence? The strategy is we went row by row and within a row from left to right, and every value we just fixed it as big as we can. Why does it work? There are several ways to explain that. For sure we will not exceed any sum. If we see that in a row the remaining sum is 5, in the column 7, then here we put 5, right? So it's not that we exceed some sum. The question is just whether everything will be fine when we are in the last row or the last column. So what happens? Let's try to create a counter test. And I'm not saying that this is wrong. I'm just saying if this is wrong, let's try to find a counter test. Maybe we already chose some value here, some value there. And if in this column we have a sum of, I don't know, 2, and in this row we have a sum, we required sum of 5, I think that this is very bad. In this situation here we cannot satisfy the row completely. I'm assuming that x and y are already chosen. Here I need to put 5 if I want to win, but I cannot. So is this some kind of counterexample? Could we do better though? X and y I chose them in like maximum possible way. I cannot increase x and y more by definition, because when I chose x, I then said that it should be maximum possible, and then I took the better limit from row and column, how many I still want, how many units I still want there. Okay, so x couldn't be bigger. Same logic for y, it couldn't be bigger. So the fact that here the row is not satisfied, it just means that something was bad from the very beginning. This has no solution. And this, for example, happens if I have the requirement for this column from the very beginning 3, and for this one it's 1, and at the beginning the value here is 9. This cannot be true, cannot be satisfied, because the maximum I can get, the maximum sum is 1 plus 3 plus 2. Or in more generally, I want this sum over row sums is equal sum over col sums. This must be true, and this is general thing in Sudoku, maybe not in Sudoku, but in any puzzles, where if you are set what is the sum in every column and you are set what is the sum in every row, then they must give the same sum, because it's equal to sum of all elements. Yep, and if this is true, then I claim that our greedy approach will work, because this is greedy. Generally, if we need to find any solution, it's not that we need to count ways to do something. then it's good enough to find something to say that, okay, let's just going from left to right for a sequence, let's decide about every next element. That's the easiest we can do. It's called greedy approach. Sometimes it's not easy to prove the greedy approach. Yeah, but if this is true, the cool thing is whenever we choose some element, sum of that and sum of this decreases by the same value. So if this is the initial situation, and now indeed 8 plus 6 plus 8, this was the sample test, second sample test. The sum of this is what? 16 plus 6, 22. The sum of that is also 22. If I imagine that at the beginning I have just zeros everywhere, the question marks are zeros, but I can keep modifying them, I can keep increasing them, then after on any cell, after I put some value, can be for example 2, the requirement about the sum is still true. Here, if I write down, if I update what's the remaining sum I want to get in the column and in the row, the sum of rows is still equal to the sum of columns. And then what I can do is I can say any cell I can increase by 1 without messing up this condition that must be true at the very beginning. Put 1 here, then the remaining value I want in the row is 6 and in the column is 5, not 6. When I change this from 0 to x, I will decrease this sum by x and this one by x. Let's put here 3, then this will be 0, and this will be 5. And as long as the numbers here are, something is non-zero, like 10, and something here is non-zero, then I can still continue, right? I can, let's say, increase this by 1, and then it will affect this one and this one. You can treat this condition as you can put 4 units in this column. This means you can put 5 units in this row, 10 units in this row. And if you put something at intersection of row and column, can be 1, can be 4 units at the same time, something will decrease. Nothing is messed up, and still the condition holds true. And important lemma, as long as there is any non-zero here and any non-zero here, I can choose them. Let's say that we already put here 6, so this makes those 0. If there's any non-zero among rows and among columns, the intersection of them is a good candidate where I can put some value. So let's put here 1. That would update as 5 and them as 5 and 5. I can directly increase by additional 5, but I could go 1 by 1. And this is another valid solution. The sum in first column is 2 plus 6, 8, then 6, then 8. That's exactly what we wanted to achieve. In rows it's 5, 7, 10. So the some proof of correctness of the greedy approach from the very beginning, where we just chose cell by cell, is that as long as we don't mess up the condition, this one, everything is fine. And we cannot mess up this condition by choosing some value, because it decreases the sum of conditions for rows and for columns by the same value. Is minimum necessary? No. In this problem, one correct solution, but very slow, would be the following. While true, do this. Let's say that it's n by n. I don't know if it's the case. If row sum of row is greater than 0 and col sum of col is greater than 0, then answer of row col plus plus, and decrease those two requirements. While true, repeat this process. Just go through the grid and try to find anything to increase it by 1. And this should be, well, not done. Not done means that we still have some requirement. If the statement said that we should, oh yeah, actually I missed this from constraint. Some rows is equal some columns. Yeah, if this is true, then we can always do a single step, so we can get closer to a solution. I would say that the easiest way to do this is either to compare it like that, where row sum is different, an array of size n filled with zeros. Either this, or you can create some Boolean flag and always mark here, if you do something, mark this Boolean flag as done, true, and then if nothing was done, once we go through the matrix, it means we can break because nothing happened. So that's the final solution. This should be a two-dimensional matrix, initially filled with zeros. Like that. Okay, and because values are big, they are here. I think that I will not get time limit exceeded, but what I will get is, yeah, I will get time limit exceeded. I wanted to say I will not get wrong answer. Is height and width the same? Not necessarily. So yeah, here we need to say that this is of size height by width. Height and width, like this. Then while row sum is different than that, row up to h, column up to w. Seems good. Let's submit just to get time limit exceeded. Our first run code. No length because vector has size, not length. How can we prove that if sum of this, then answer exists? Yeah, I proved that, but I will repeat. I said that whenever one of requirements for columns is non-zero and one of requirements for rows is non-zero, then there exists an intersection of such non-zero and non-zero, and I can increase it by 1. So while conditions are not satisfied, I can increase something by 1. I can just get closer to the answer because I decreased the sum of conditions and I didn't mess up anything. The condition about the sum of rows, and the sum of rows will decrease by 1, the sum of columns will decrease by 1. Maybe initially it's like what here it was 22 and 22. After every single operation I do, it is smaller by 1, so I will make 22 operations in total. And I showed how always there is an intersection of two non-zeros, so I will find a cell where something can be done. I don't know. A much simpler problem would be, imagine that there is an array of some values. Let's say that initially an array is like 5, 8, 6, 10. And I say that the sum of those values is too big. I say that I want the sum of values to be equal to 14. Then imagine this solution. While sum greater than 14, iterate over everything. If a of I is still positive, a of I minus minus, sum of everything minus minus. This will always find a thing to decrease, because for sure not everything is zeros. There is any non-zero. I assume that this is the starting array and I don't want to go below 0, but I want the sum of numbers to be 14 and I'm only allowed to decrease values. Then this works. So this is an easier example of easier explanation of why this works in our problem. Okay, but finally, to make things much faster, I will do this. It works for the same reason. Like if I see 5 here and 7 here, I will increase this value in the middle by 5. And it doesn't hurt. No condition changed to some negative thing or what. The sum is still the same. Yeah, like that. It should be the same, just faster. We can talk about time complexity because I implemented it in some strange way, because here I still have this. But I think it's equivalent to getting rid of this condition, so of the while loop. So let's remove that. And let's shift this to the left and submit again, because we just go through all the cells once, and for each of them we just maximize it. If we see that I can use 7 more units in this column, 5 more in this row, I put 5 here. Harder version, if it is 3-dimensional, it will be the same. Everything will work the same way. It would just be about one more for loop here to iterate over that last dimension. Just like it works for in 1 dimension, in 2 dimensions, same thing will work in 3 or 4 dimensions. Would it be possible to do this problem best by, you want some dynamic programming, Obito? Maybe. Maybe, we'll see. First we'll do the second homework problem. Are there any questions about this? And Twitch only, like if you're watching on YouTube, open Twitch chat to discuss. And how do you like this format of homework problem? Was it too detailed? Do you want me to talk through more examples? Do you want easier problems, harder problems? You can either say now or like later in Discord. Can't we do better time complexity wise? That's a good question, but a very easy one to answer in this problem, because our time complexity is equal to size of the output. I have 2 for loops over rows and columns, so time complexity is h times w, and both time and space, because I create such a 2-dimensional array here, or a vector, and I need to return it. So for sure I need to create it, and then just creation alone takes that much time. So this is optimal. It's quite rare that we can say it. It's usually very difficult to prove that something is optimal unless it's exactly of size of input or output. For example, sorting. The best we can do when sorting just by using comparisons is n log n. And there exists a proof why it's n log n, but it isn't for beginners. And to actually prove that, for example, knapsack cannot be done in exponential time, computer scientists think about it for many years already. It's whether p is equal np. That's a very well-known problem. I think there is a price of $1 million if you figure it out. But this time it was easy to answer. That's the optimal complexity, because we need to return something, and it's exactly of this size. So, guy of nick Camille in Twitch, please don't spam. I've been troubled by the merge stones problem the entire weekend. Then in a moment we'll do it. Where should I go if I figure out? If you figure out if you solve the homework? This is what you mean? Jaiski, I don't know what you're asking about. Let me update the link. This is the second homework problem of around number 1000 in Leetcode. And I assume that either that you know a problem or you watched the previous week, because we already then discussed k equal to 2. And in this problem we need drawings for sure. P equal NP, where should I go if I figure it out? You should write down your proof and publish it. But oh, I didn't update the link. Why? How? Oh, I needed to click save. Let's try the link again. Yeah, if you figure out if P is equal NP, then you can also use Google to find out what exactly to do to collect your price. Chiamaka, I will not take any request now, maybe after the homework. Okay, in this problem we have some numbers at the beginning, 3, 2, 4, 1, and some value k equal to 2, and this way we know how many consecutive piles we take, and we merge them to their sum. This is now 5, and for this we pay the cost of 5. Then we merge maybe those two, again the cost would be 5, then 5 with 5, the cost will be 10. We need to minimize the sum of costs of all our operations. But k can be big, and this is the length of interval to use. And we talked already last week that we will go from the end. The example isn't that important. Okay, we go from the end. What does it mean? We know that the initial sequence is something, and we know the sum of all elements. So we know, for example, that this, I don't know, sum of all is equal maybe 52. And now I wonder, what was the situation just before the last operation? Just before the last operation, for sure I had exactly k numbers, and each of them came from some consecutive interval of the sequence. Let's say that k is equal 4. Then it's something like that. And it would be too slow, but I can iterate over all possible splits, all possible ways to put 3 such bars between numbers, between some positions. And I will say that, well, I wonder what's the optimal way to merge this into a single value, to merge this into a single value, and to merge this and this each into a single value. And I will take such, this is, let's say, dp of 1, 3. I want to already know what's the optimal answer if we just focus on this sequence, because this is from position 1 to position 3, plus dp of from position 4 to 5, 6, 7, 8, from 4 to 8, 8 plus, no, plus those two, this one and this one, plus the sum of all numbers, so plus 52. Exponential but correct solution. Exponential, so too slow. But correct is to iterate over those splits and say that dp from 1 to n is the minimum of those possibilities. I just iterate over possible situation just before the last move. I know that every number at every moment of this process, it comes from some interval of the initial sequence. In particular, if the values at the beginning are 3, 1, 7, and 2, it's not that I can get 5 ever in the sequence. If I merge some consecutive values, I will get a new value, and it's sum of interval of the initial sequence. Like maybe here I will create 8. Maybe in one operation, or like 2 operations, if k is small, maybe here I will create 11. Each number will come from interval of the sequence. What are these splits based on? We iterate over the splits. I'm just saying that at every moment the sequence shorter already, every number comes from interval of the initial sequence. For example, if let's take this 3, 5, 1, 2, 6. One possibility of what happens just before the last final merge is that the sequence looks like this. Okay? This would correspond to putting splits in those two positions. It means that this interval is now a single number, this interval is a single number, and this one is a single number. Maybe some splits are impossible. For example, for k equal to 6, this is impossible, Because how would you merge two elements into one? You need to take three consecutive elements. This reminds me of your video where you solved burst balloons. Yeah, it is related or the same, right? Okay, so slow version, iterate over splits. But this can be done better with DP. We already are using DP, and we will use DP within our DP. How to do it? Well, we have a new problem, so let's state it. If already we did our DP for shorter intervals, so for any interval we can easily access in some two-dimensional array what's the optimal way to merge this into a single element. After we are done with that, I want to split the whole interval optimally into 4 intervals. And for each of them I get a cost. And this could be a problem in itself. You're given two-dimensional array. For every interval it says what's the cost of having interval from I to j, and split the full interval optimally into k shorter intervals. Okay, how do we approach that? We need to think about it as a DP problem. Generally here, by the way, the very first hint that should tell you that it might be DP is that limits are small. Well, if limits are around 30 or 100, something like that, it's very often dynamic programming, because dynamic programming can be quadratic, cubic, something like that. If it's something greedy, where you sort and choose smallest value or whatever, limits would be bigger. So that's your first hint. The other one is as follows. The different solutions we would consider with brute force are similar. If I just move this bar a little bit to the right, this doesn't change. DP is about solving some big problem consisting of sub-problems, and those sub-problems often repeat themselves. Okay, so those are some reasons why we should at all think that this is DP. Yep, DP within DP. So nice. Okay, you're given a sequence. The easiest way to think about DP, I have those lectures on YouTube where I teach you that you should think what is important so far. But it helps a lot to imagine that there is some movement, or we do something with the sequence going from left to right, like deciding about every element or something like that. For example, it's very easy to solve a problem where there is a frog on let's say there are stones, n stones numbered from 1 all the way to n. There is a frog on the first stone, and the frog can jump by 2 or by 1. Compute the number of ways to get to the last stone. This is the easiest possible DP problem, where you just say that DP of a cell is the sum of 2 previous DP values. If you know that there are 5 ways to get here, 8 ways to get here, then there will be 13 ways to get here, because then you jump like that. You need to already know something like that to approach this problem. If you don't, sorry, you have no chance to understand. Watch my DP videos on YouTube. Okay, so let's think about this problem as some kind of maybe frog jumping through the sequence. And yeah, that's possible. We have some splits, so we have some intervals. Let's treat something like that as some kind of frog, starting maybe in the very beginning. Let's say that this is the first split, and then it jumps to every next split. And this time we have a cost. There is a cost of jumping from one position to the other, and we know it. We can read from DP array. And we want to make exactly 4 jumps. If you want to make 4 jumps with a frog, starting from the very first position, then whenever you are somewhere, let's say that now we are here, then what is important so far? What do you need to know how to finish this? To know that after a few more moves you will be at the end and you will finish. Obviously it's important where we are, the current position, and how many steps we already made, or how many jumps. Let's call it jumps. And because they ask us to minimize the total cost, then the total cost. Those three things are necessary. If you were to write any simulation of this process, if you were to simulate it with brute force, to iterate over all possible ways to split the sequence into 4, then to verify if something is valid, like it must contain a proper number of jumps, and you need to compute the cost. And obviously every next position is important. Like if you want to simulate anything here in constant space, those three values is what you need. And then because we minimize this will be int the value of our dp. So let's call it dp frog of, and the other two remaining values we need to maintain, we put as dimensions. So this is the position, and this is the jump, how many jumps we made. Sorry for ugly font, in a moment I will implement that, so it will be nicer. Okay, this was version with k equal to 2, but I think we just completely get rid of it. We can get rid of it right now. That was a week ago. Yeah, so dp frog, I said that we need dp frog of position and how many jumps it already made. Or in other words, this is what's the, and this is int. So the definition of that is minimum cost to already do some intervals on first that many positions, because now we are at that position, using that many jumps or that many intervals. For example, dp frog of 5 and 2 is min cost to split the first 5 elements into 2 intervals. Writing down the definition might be quite useful if you're not sure what you're doing. Okay, so that's an example. And how do we do transitions? I will do this in iterative way because that's quite easy. Iterate over position, yeah, can be I, can be j. For every position from 0 to n minus 1, let's say that this is the beginning of next interval. So we first start from this. There is cost 0 to get to this state. Now going from this one to something in the future, I also iterate over the number of jumps already made. I cannot make exactly k because I will not get to the end. Iterate over like where to jump, new position, let's say. Here I'm quite experienced, so I know better whether to put here smaller or smaller equal, but I will go through that. Are you allowed to sort the array? No, I'm not. That's the full statement. There is nothing about reordering stuff. New position, and yeah, I will here move from this state to dp frog of new position and jumps plus 1. If I want exactly k consecutive piles, at the end I'm interested in dp frog of n of what exactly k. Yep, and I need to decide about indices. So here I assumed that, well, if this is 0, then 1, 2, and so on, then this would be n minus 1, because if I have here numbering from 1 to n, then we see that this is how it corresponds. 1 means that after a moment, splitting here means 1. So if this is n minus 1, then splitting here means n minus 1, and the last split I want to have at n. This is visual way to figure out if I need n or n minus 1. So doing a split from from position 3 to position 4, 5, 6 would be to move from position 3 to new position equal to 6. Yeah, and then like this sub-interval is I need to take cost from that. So this line will exactly be implemented like that. New position jumps plus 1 is minimum of itself, comma, and for itself I will copy. I can also create a function maybe for that. Comma. dp frog of position jumps plus some dp cost of interval. Cost interval, and this cost interval is done with the first dp of position, and here new position, assuming that we have proper indexing. Yep, here we go. So that's what I would write down on a piece of paper, that from this state we move to this one, but in actual code we have this. New state is minimum of itself and previous state plus cost of transition. I'm sure that a lot of you are used to recursive implementation, but just iterative implementation of DP is more powerful. It's faster, it's easier to figure out the complexity, and some difficult techniques can be used while in recursion they cannot be used. So iterative DP is better. And you know, it's just about iterating over states, and then after you do that, iterating over transition. And I know that from this state, if I know that I'm on this position and I already made 2 jumps, I iterate over what will be the third jump, and I have some new state. Less intuitive for noobs? Not really. It's only less intuitive for people who already know recursion. But I think that people who just know recursion and they try some DP problems with recursion, a lot of time they guess what needs to be done. And whenever problem becomes harder, it becomes hard to guess. Any reason you would use a recursive solution? Yes, but I discussed the differences in that YouTube lecture. For now, we assume that iterative is just better, but yes, it's not 100% of cases. It's 99 or 95% of cases where iterative is better. Okay, what is cost interval? The cost of interval is what's the optimal way to split interval, to merge everything from interval to one value. What I'm actually here computing is cost interval. Let's say that we do it inclusively from this position to this position. And at the end, I will actually return cost interval from 0 to n-1. If I have this inclusive indices, then actually I will put here -1. Why? Because when I jump from 3 to 6, on that drawing it happened, the numbers I have between them is 3, 4, 5. There are 3 numbers between 3 and 6. The length of a jump is 6. What you should do is on a piece of paper you should write down, yeah, I will just do it. I want to work with 0 indexing, so there are values 0, 1, 2, 3, 4. Let's say that n is equal to 5, and there are split points. This one is 0, this one is 1, 2, 3, 4, and 5. Okay, when we jump from split point 0 to split point 3, the numbers we merge are those from indices 0, 1, 2. This is why I said from position to new position -1. Okay, don't guess, just to write down some easy example and see if it needs to be -1 or not. I forgot semicolon. I didn't. This is not a definition. What I will need to put here is this will be eventually a 2-dimensional vector. So treat this as a comment. Okay, but how do I know cost interval of shorter stuff, I need to compute it with dp. And this will make the code uglier, sadly. But well, what can you do? This is a way to compute cost interval from 0 to n-1. I need to compute the answer for every shorter interval too. So what about doing and this will be wrong, I will later, or maybe not, I will later correct it. Let's here try to compute cost interval of LR. And in iterative DP you need to care about order, and later we will get back to those for loops and see if they are fine or not. So let's say that this is what I want from my code, and how to compute optimal way to merge some interval in a single value with our frog DP. So all of this I actually need to put here with proper indentation. And this time, yeah, DP of this changes a little bit. Starting from position L with 0 jumps already. Let's remember that this was DP frog of position and how many jumps. I also need to create this DP, but that in a moment. Now for every position from L to R, right? Position is the first element of a new block to do. So yeah, this is good. For the number of jumps so far, for every new position up to R+1, like for example, if I'm at position R, I still need to handle this number. If I just take the single number, I will jump to R+1. Do this cost interval from L to R is equal dp frog of R+1. Okay, just like a moment ago, notice that I already figured out that if I want interval from 0 to n-1, it's at dp frog of this last position plus 1. That's because, let's look at drawing, to finish at number 4, I now want to split point at 4 plus 1. Okay, such drawings are extremely helpful when you do some problem where you need to care about smaller, equal, plus, minus 1. Always create such a drawing, just, you know, on paper. Okay, return this. That was the full definition. We're getting there. The main code is done. I still didn't create the DP. Let's do it here. So for those who don't use C++, imagine that this is just dp frog of what, n+1 I think I need. Also I kept using lowercase n, n+1 by k+1. This way I have indices up to n and I have jumps up to k. It's good to use vectors in modern C++, and sadly this is what you need to do. You would be fine with two-dimensional array. This is by default filled with zeros, and that's actually bad. I want this to be 0. I know that with cost 0 I can start here, but I don't want to say that I can at cost 0 be at the very end. So by default, when you minimize with dp, by default fill it with infinity. That would represent the impossible state. And for sure from 0 you will improve stuff. Let's put it here as billion plus 5. I don't like using int max because then it's very easy to make an overflow. If you try to add int max to something else, it overflows. That's bad. Billion 5 is better. It's commonly used in competitive programming. Okay, but we also compute cost interval, again two-dimensional array. By default filled with infinities. And one final thing is that whether this will work this will not work for intervals of size 1 because we don't have any split into intervals, into k intervals. I need to say if L is equal R, cost interval of LR is 0. It doesn't cost anything to merge a single value into a single value. Otherwise, we have some optimal cost of splitting plus sum of values. Could be improved with prefix sums, but doesn't affect the complexity, so I'm not doing it. This is the first moment when I'm using stones. It would be very suspicious if I didn't use stones ever. Yeah. They defined in the statement cost of splitting as the sum of all values, so the new value. And here in DP I say that to merge everything from L to R into a single value, this DP frog says what's the optimal cost to split each of those shorter intervals into a single value, plus those single values I need to merge into one value. Like for example, if I knew that this part can be merged with cost 20 into a single value, and that single value is maybe 10, then this one with cost 15, this one with cost 20, then I know that the answer, the total answer is the sum of those, 55, plus the sum of all numbers, sum of all elements from the input. Because to merge those three values to one, I have this cost, the cost of sum. Oof. Yeah, did I miss something? Let's run and fix some compilation errors. Wrong answer. And now we will have some testing lesson maybe, because I didn't get a correct answer. And generally in programming it's not that you will always get a correct answer after writing 30 lines of code. It happens, but fortunately we can print stuff and we can understand it better. For k equal to 2, and for this input, I outputted a big number. That's clearly my infinity, or something could be even bigger. Something is wrong. I can, I can print what I'm making, and I can, for example, print L, R, cost interval of LR. Tell your program to show you what it printed, what it computed. For 0, 1, the answer is apparently billion. That shouldn't be the case here. From 0 to 1, it's the cost of merging this into a single value. That should be just 5. Instead, I got infinity plus 5. That's bad. So this is the DP frog thing is infinity instead of 0. Yeah, infinity instead of 0. I could additionally here print this DP frog to make sure what it is. I could make some more prints here. And then you would figure out, already 5 seconds ago I figured out. Yeah, and somebody in the chat has just figured this out as well. It's reversed order of L iterations. But let me finish saying how you would get to that. When you think that DPs should be different value, for sure not infinity, then on paper you can figure out from what DP states you would get that. The fact that those two values, the input is 3, 2, 4, 1, how to optimally do this part? Well, the frog will just jump from here to here. Is that correct? Oh no, we split into k intervals, so frog will jump like that. Because every jump, it corresponds to one interval, and we want to merge them. Then here we can print what is dp of this, so dp frog uses cost interval. So I wonder what is cost interval of 0, 1, or whatever thing I'm using. Also, what is cost interval of this? They should be 0, because I initialize them as 0 here. But if you print that, you would see that it isn't the case. And that's because of the order of our for loops. If I say if L is 0 and R is 1, print cost interval of, for example, 1, 2, I guarantee you that this will be infinity. Am I doing something correctly? The cost interval, I'm interested in cost interval of 1, 1 actually. Not submit, sorry. That will not be correct. Run and for the sample test. Billion5 was printed. Cost interval of 1, 1, just to show you, this should be 0. And you would figure this out after like 5 minutes of printing stuff. This should be 0 is a value billion5. How is it possible, even though here I decide that cost interval for L equal to R is 0? For every L, for R at some moment is equal to L, so I will mark cost interval of 0, 0 as 0. I will mark cost interval of 1, 1 as 0, of 2, 2 as 0, and so on. Every cost interval of I must be 0. So how can this be infinity? That's because of the order of doing operations. Initially everything is infinity, and before we get to operation cost interval of 1, 1 is 0, before we get to this, I already tried to use it. In iterative DP has one big disadvantage against recursive DP. You need to care about the order, how you compute DP. And when I wrote those two for loops, I told you that we will get back to this. Longer intervals, they use DP value of shorter intervals. The whole DP is about saying that something is already computed and I use it. If case 2, then if I know how to merge this optimally into a single value of maybe 7, this into a single value, maybe 9, if I know what's the cost to do this merge, then I can say that this can be merged into a single value in some cost. But before doing this interval from 1 to 5, I already need to be done with intervals from 1 to 3 and from 4 to 5. And I will repeat, before I do interval from 1 to 5, I need to do interval from 4 to 5, the shorter one. But that's not the case here. I iterate mainly, the first for loop is over L. When I try to compute the main DP, so cost interval of 0, 4, when I try to compute this, cost interval of, for example, 3 to 4 isn't computed. I need to go in order of from short intervals to big intervals. And there are two ways for that. The first one is to first iterate over the length of interval, and then here figure out some way to iterate over, to try every interval of this length, like from 0 to 0. For len equal to 3, you would need to try intervals 0, 2, 1, 3, 2, 4, and so on, because each of them has 3 elements, like this one, it has 2, 3, 4. That's one possibility. The other is to just fix those for loops, and here this will be the fix. I start from L equal to n minus 1. When I'm at L equal 5, I'm already done with L equal 6 and everything bigger. This is good order, because when I have, for example, 4, 10, then everything that starts after 4, like 4 anything, is already computed. Everything like 6 comma something is already computed. What about 4 comma 8? Because maybe 4 comma 10 will use as subinterval 4 comma 8. This is already computed before 410 because of the order of this for loop. And that's how you figure out the order of for loops in iterative DP. It must be in such a way that bigger state, using smaller states, already can access already computed with DP smaller states. Now I bet that this should be 0 will be indeed 0. Yeah, this should be 0 is equal to 0. Output is 20, expected 20. And I will just remove this because it might give me time limit exceeded. Printing is time expensive. You are allowed in Leetcode to submit with some unnecessary prints, but it isn't good to do so. Wrong answer. I printed infinity where expected is -1. Well, actually, the fact that I'm printing infinity, it means that my program didn't find any solution. Infinity is fake value denoting impossibility. So I need to say if cost interval of 0 and -1 is greater or equal infinity, to -1. And now I will tell you, okay, easy. Question to the audience. Why is it possible that the answer is impossible? However stupid that sentence was. In this problem, describe an example where we should return -1 without looking at samples. It's easy to explain such an example. And yeah, that's the full code we got accepted. And I will just discuss time complexity now. We just look at for loops. There is one, so of size n times n times n times k, n times n. Because we iterate over position, 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 jumps, and position. That was n, 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 k, n. So n to fourth, n, 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 k, and n. K times n to fourth power, I believe. And that's reasonable for those limits. 30 to fourth power is around 1 million. So roughly you get something of magnitude 30 million operations. That's fast enough. When k equal to 1, I don't think k equal to 1 is allowed, but for example, yes, when k is greater than n. When our frog cannot make k jumps. There are some more complicated examples, like consider that k is 5 and our sequence is of size 6. Then if this is the sequence, in first operation we will merge 5 elements into one, and then we will have just two numbers, x and y. Let's say that this was x and we merge those 5 values into y. We cannot use merge of k operation of k elements if we have just 2 and k is equal to 5. In general, this is how to figure out what's impossible. iWatch Coding gave us the formula exactly. Lemma: every operation, every merge operation decreases the number of elements by k minus 1. If we merge 5 elements into one, the number of elements decreased by 4. This is true, and I want from n to get just one element. So I want in total to decrease by n minus 1. So n minus 1 must be divisible by k minus 1. That's the condition we need so that there would be a solution. For example, if n is 10 and k is 4, then it's possible because n minus 1, 9, is divisible by 3. Initially we have 10 elements, then 4 of them will be merged to 1. We are left with 7 elements. Then 4, then finally from 4 elements we have 1. The number of elements decreases by k minus 1, and in total from the beginning to the end it should decrease by n minus 1. Please install the Dark Reader extension. I don't need to install it, it's here. It's not necessary everywhere. Leetcode is anyway half black with this code editor, so I'm fine. And yep, if you want to get some more explanation on iterative versus recursive DP, watch the lectures on YouTube. If you Google YouTube Errichto DP lectures, you will find dynamic programming lecture number 1, 2, 3. So I will not even give you a link, just search if you want. Okay, that's it for the homework from last week. I tried to explain this in detail because I believe that this is a difficult problem if you are not a competitive programmer. Check the discuss section. Sure. Should I sort by most votes? No, it's just a little bit better. I actually see why. For example, they used prefix sums, but it doesn't affect my complexity because I compute sum not in the bottleneck of my solution. Yeah, I understand this, but once you are given this sentence, then sure, you can create an easier solution. But I described to you what to do for k equal to 2, and then for general k, I want to merge k piles, so I want to figure out how to split some interval optimally into k piles. This makes sense, you can derive that yourself. Here it's harder. And a way for me to get this directly is to notice what unnecessary work I'm doing. And also then I will get k times n to third power, not fourth power. And that's because for every L, when I see here, I start from position equal to L, and I will do exactly the same thing. This dp frog, when I have, for example, L equal 5, R equal 10. And later I have L equal 4, L equal 5, R equal 9. For R equal 9, for this pair, this will exactly repeat the work I already did. Because we start from position 5 and I investigate what's the optimal way for frog to jump to the right with some number of jumps. So for every L, I should just run those lines once for R equal to maximum possible R, and I should remember that dp. And then because I don't run it again and again for every R, the complexity will be better by n. But treat that as an extra homework. See the lower solution to just 3 for loops. Okay, I can take a look. I mean this one. What do you mean by lower solution? Solution to in that same? This? Wait, is this divided by k? Oh, because they use the fact that n must be divisible by something. So, no, that's a good observation, but wait, oh, the wrong problem, sorry. Yeah, here, instead of trying every pair LR, only try it when R minus L, so length of this interval, is divisible by k minus 1. Just like we talked about a moment before. This is how you will get divided by k, I guess. Yeah, this time we merge two interval into one. Wait, this is for k equal to 2. Oh, dp of ij, the definition of dp is the most important. Means the minimum cost needed to merge stones from I to j. Okay, then dp of I mid plus dp of mid plus 1 to j. I don't see how this works for arbitrary k. Oh, we'll merge as much as possible. So this is just some crazy trick, very unusual one, where we very much modify the definition of dp. dp of ij isn't answer for interval ij, is instead some minimum cost to merge it as much as possible. So to as few elements as we can, I think. Then that's very tricky, I believe, if I understood correctly. Please explain the line for this one. I explained. I will not. You can rewind or watch on YouTube later. I explained for 5 minutes what's up with the order of computing states. Okay, and again, either now or later on Discord, you can tell me what you think about this, about those exact homework problems, and whether my explanations were too vague, too fast, too slow. What do you expect from this? I'm not doing this, for myself, to make it as convenient or cool for me. I'm doing this for you to learn something. And now let's do like 1-2 minute break, and then I will grab some problem from suggestions and we'll solve it. What does that code in the discuss section, what did he do? You can read the description. I said something about that code. I could now spend 15 minutes explaining that code, but I told it's enough that I told you how to improve this by n factor. Believe me that anything more would not be required during an interview. Is the stream over, or will you solve more problems? I will solve something more. I think that's enough of DP for today. I see in the Twitch chat some suggestions for DP problems. Anuna in YouTube asks, what happened to my old channel? Nothing? Why would something happen? My channel still exists and is doing well. If you're asking why there is no new video for past 2 or 3 weeks, because I didn't make one. If you look at the history, it happened all the time that I would have like 1 or 2 months of break. It takes a lot of time to make those lectures for the main YouTube channel. So sometimes there is a break for 1 month. Currently what is in works is Gaussian elimination for code versus edu section. But I also might grab some easy problem from Leetcode or code forces and just discuss it and put on YouTube. Segment 3, that's not required for coding interviews. Circle and rectangle overlapping. That doesn't sound fun. It will be just formulas. Course schedule 4 by Great Coder. I think that will be DP or not. This is topological graph. Let me take a look. We are given a directed graph and with edges saying that this course must be before that one, and we need to say if this one must go before that other thing. So whether there exists a path from A to B. and it can be done with brute force, I guess. What's the number of queries? This. Okay, so it cannot be done with brute force, and it needs to be done with topological sort. I don't feel like explaining the whole of topological sort today. It's just a topic for a lecture. Oh, that's Floyd-Warshall, or okay, so there are some topological sorts. There is also Floyd-Warshall. Makes sense, but it's slower. It's significantly slower. The best solution here will be topological sort. It's linear of size of the graph. Okay, something else. It's just Floyd-Warshall. Not just Floyd-Warshall. Not just Floyd-Warshall here is not the optimal solution. It's n-cubic, while it's possible to do it better. In just of size of the graph. But yeah, something like topological sort can be done in quadratic time too. Actually, yeah, if you want to do this problem, make yourself a challenge of doing it in quadratic time. I think topological sort can be done in quadratic time, n square, even if you don't know any good algorithm. Good algorithm solves it in O of number of edges. So if the graph isn't dense, it's still very good. Works for a number of vertices and edges of size around 100,000. But here, yeah, please explain the toposort approach. Just, as I said, this is topic for a lecture. I prefer solving smaller random problems. Maybe one day I will make a video. Okay, what else is in the suggestions? Yeah. Chamaka still suggests the one with binary search. Do we want binary search? I can do it. For some time I didn't do binary search. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. I will modify the link command. Find minimum element in rotated sorted array. Rotated means shifted here. YouTube chat, as a reminder, if you want to discuss something, if you want to ask questions, go to Twitch chat. Okay. When something is sorted, you should in first seconds think about binary search. That should be obvious. Or if you can sort something and then if you can sort and then you search for some value, think about binary search always. I'm not saying that it will always work, just think about it, consider it. This time we know that sequence is like that, increasing, then drops, then increasing again, like 4, 5, 6, 7, 0, 1, 2. We need to find this minimum element. The way to think about binary search is that you're given, there is some sequence, but you don't know it. You want to binary search in it, and when it's increasing and you're looking for value x equal to 7, when you ask about middle element and it's 12, you know to which half you should go, to the left half, because 7 must be there. So there you forget about the right part, you ask about middle element, it's 5, oh, then apparently you need to go to right part. Remove that and just ask about this final element. That's binary search. It's very good to think about this unknown sequence and asking about middle element. Instead of writing down the whole sequence, just write down underscores, because your program doesn't know the whole sequence. It can look just as a single value. What about here? Instead of searching for value, like x equal to 7, we have this almost increasing sequence. We ask about middle element. Let's say that it's 5. How can we know where is minimum? We cannot know. I can tell you examples where minimum will be on the right and on the left for such a sequence where we just know that this is 5. It will be, for example, on the left if this is 3, and then this is 10, 11, here 6, 7, 8, 9. Okay, so minimum can be on the left from 5. And also minimum can be here. Consider this, 8, 9, then 1, 2, 3, 4, 4. I'm out of numbers, but doesn't matter. You get the point. It's not enough to ask about this number. Then you can try, oh, maybe I need to also ask about a neighbor. But still, the same is still true. You cannot, by asking about 2 middle elements, or even 10 middle elements, figure out if this sequence, if it's increasing here, if it will drop on the right, or maybe on the right it's increasing for the whole time, and on the left it has minimum, and the drop is on the left. Okay, so what do we need to do to figure that out? The cases where that there is drop on the right, or it's increasing for the whole time on the right. Okay, if there is a drop here, then values on the right eventually will become small, smaller than 5 in particular. Maybe it's 7, 9, but then it will be 1 and 2. So with this logic, with the logic of trying to figure out, but can I decide to which half I should go by asking about middle element, we can get to the fact that it would be nice to ask about, for example, last element. That's not the only possibility, but let's do that. If this value is big, it means I am increasing from 5 up to the right. If it's smaller than 5, it means there was a drop. It's impossible that there was a drop like this, and here maybe 1, 2, and 7. This is not valid input. They said that this was a sorted array and it was shifted a little bit. Okay, this is not possible. If the last value is 7 or just anything big, it means that this part is increasing. So the minimum is on the left. So we have idea for this logic. If a of mid is smaller than or nums, this is, I hate this name for an array. If a of middle is smaller than a of last, then what? Go to left part. Else go to right part. And there are some details like, oh, what about exactly this element? We need to figure out this off by one thing. But if the minimum is somewhere here, maybe the last element, maybe this one, then this last element must be smaller than 5. What if there is constant values in the right and something like this? Okay, let's see. What if it's this? Well, here, if we don't know the sequence and we ask about middle element like 7, and we ask about last element like 2, we will figure out that there was a drop on the right. So we will correctly go to the right part. In your example, who said that? Prabham, in your example everything works, but it also, there is another example, and for that one it will not work. 1, 2, 3, 3, 3. For that one still everything is fine. Here's a good example. If before rotation this was an array, and now it's something like that. Here, when you look at middle element 2, and you look at, let's say, first and last element, you cannot decide to which half you should go. This is an example of an array where it's impossible in logarithmic time to find the minimum. The array may contain duplicates. This is bullshit. If this is the only condition, then it's impossible to solve this problem. Would allow duplicates affect the runtime complexity? How and why? Yes, and this is an example. If the array has a single odd value, odd meaning like not matching everything else, you need linear search to find it, unless you have some extra information about the array. Because this single one can be in any of n elements. So without asking about all elements, or maybe all but one, you cannot find it. Our logic here worked for no duplicates, if it's indeed increasing. We can figure out the exact condition. I think the exact condition will be something like maybe, can we have duplicates or not? Maybe like half of the array at most can be duplicates. I want to say, okay, if this is strictly smaller than me, then I know there was a drop here, and one of those elements is minimums. That's fine. If this is strictly greater, then it means this could there be a drop here? There couldn't. The only bad condition is this. If it's 5 and 5, I don't know where to go. Yep, that's all. That's basically it. If I meet such a case, I cannot figure out where to go. What if the array is 2, 2, 2, 2, 2? Then if it's all the same elements, then for sure you will find the minimum. If mid is exactly equal to end, then decrease end. Same goes for start. Like, no, you cannot solve this case, because no matter you do, based on, like, this is how you should think about counterexamples. It's incorrect to say that you know what to do if the middle value is 2, the last value is 2, and maybe also, I don't know, the first value is 2 if you want to check it. Because if your algorithm goes to that part, what if this is the input? What if everything is 2 except for this value? If you say that, okay, go to the left, what if 1 is here? No matter what your algorithm is, there is a counterexample against it. That's why I said 1, 2, 3, 4, 3. Okay, then you are right. Ice cream killer. But here, if we just compare middle with right, generally, looking at this, we cannot figure out what happens. Go randomized, then again, it will not work. Because for any test, like if you want to 20 times go to left or right half, the probability that you will find exactly this one element is like 1 over n. It will be 1 over 2 to 20th, 1 millionth chance. You need to go linearly here to distinguish between n possibilities. Because asking about any two doesn't give you any information. Any of remaining non-asked values can be that missing one. So, stupid problem. This sadly happens on Leetcode quite a lot. Leetcode isn't a competitive programming platform. It's not that every problem is tested by somebody strong. I wonder if there is some good discussion. To avoid this, we can add the following judgment. So is this linear in some cases? Oh yeah, here we have a linear case, high minus minus, so then obviously it's not binary search. I don't really want to implement this, because I don't know what are tests. Should I go linearly then, if there are duplicates? Sure, I can iterate for the whole array and find the minimum, but that's a bit stupid. Let's move on to some next problem. Why don't I Vim? Because I Genie. YouTube, if you want to ask about anything, go to Twitch chat. Okay, I got several problems. Binary tree maximum path sum permutation. Basically, I'm just looking at the chat, and looking at problem title is enough to figure out what the problem is about. But there's bigger chance that I choose your problem if you write something short like medium greedy is fine. or I have this suggestion, but hearing you explain might teach me better. Yet, just say anything about the problem. Same question with no duplicates. Okay, then I would say that this is worth implementing if you want to practice binary search. No duplicate exists. Okay, then I won't be surprised if I already have a video on this problem on YouTube. But again, just like with DP, on YouTube you will find my binary search comprehensive lecture. It's quite difficult, but it will show you the way I think about binary search. Regions cut by slashes. I wonder what this is. Yes, you have video on this problem? Yes, you do. Okay, thank you. I don't have good memory. Sorry about that. Eventually, I bet that it will happen for me to make a video on problem I already had made a video on. In n by n grid. First, I will just read to decide if this is good enough to discuss it. Return the number of regions. We can do that. I will check out some other propositions and we will together choose the problem. Maximum sum circular subarray. Maybe I also did this one in like April Leetcode challenge. Because on my main channel I have this, if you are into Leetcode, then for sure check out those 30 videos on Leetcode. There should also be a playlist for that, I bet. Yeah, Leetcode 30-day challenge. You will find this quite useful and maybe also entertaining. There's max subarray, so that's the easy one. Maybe not. Is this the standard problem? Okay, then I must be wrong, where I say that I already did that. Now I want that cadence implementation in circular subarray, but there is a trick for circular subarray. I know in the speedrun, I did speedrun with Alex Wise and William also joined. Yeah, we had circular subarray there. Okay, yeah. Now I remember. Caleb, I will not do the geometry problem. It doesn't seem fun. October question based on interval permutation sequence. Implement the circular thing. I implemented during the speed run. Find the 1 hour speed run, Leetcode speed run. Have you seen mine, Greedy Medium? Yeah, I saw it. Just other titles seemed more interesting. JSK. The set of this has that many permutations. Return the cave permutation. Okay, I don't want to do backtracking or counting today. Preimage size of factorial. Let this be the number of zeros at the end of x factorial. Okay, this is possible. So we have one math problem, one graph problem, and we have this sum. So let's choose between them. I can actually check. if the voting works. I will show you email from Twitch support. That was so annoying. Maybe they fixed. Still service error. Give me a second, I will show you a funny email. Will this work? I just don't want to show you anything private. Okay, there's nothing private here. Well, there is. So annoying. Okay, no. So I contacted Twitch, and via the online form on the website, I told them this is the error I'm getting, this is how to create it. I tried different browsers, computers, incognito mode. I tried many things, and I included a screenshot because it was possible there to include files. So I did everything there is for them, like to make it easy for them to debug or to reproduce the mistake. Then after 1 hour or something, I got an email, obviously automatic email, or just somebody clicked and copy pasted, where thanks for contacting about the issue. Try the following steps, like disable add-ons, extensions, replicate this issue in incognito window, private. Obviously they didn't read my message. Try a different browser. I told them that I used more than one, and I listed down browsers I used. I even told them that I used Windows and Linux. So I will stop showing for a moment. I replied to them that I appreciate the automatic reply, but try those steps as I said in the first message, but here you go. And I again attached the screenshot, even though I already gave them that. I waited 4 days, and after 4 days, I will show you this. A moment ago I showed you this email, and then after 3 days, sorry, October 11th and October 14th, I got this, and this is exactly the same automatic message. I think I can click that. Yeah, I can. Cool. I again got the same list of 5 steps. Thank you, Twitch support. Very nice. So it was very frustrating, because still I cannot do polls built in Twitch. I can still use some external website, but that's just not convenient. Yeah, I will use Stropel. This is the most frustrated I have ever seen Errichto. Did you see me solving problems for several hours? Okay, we have 3 choices: math, graph, or sum. This is the grid thing, and some circular. Allow multiple answers, sure, create the poll. Here you go, Twitch. And YouTube as well. Does Errichto read YouTube chat? Usually not. Guys, which one you're voting? you know, if you don't know what to vote on, then you can just skip. I enjoy problem solving. The frustration of not being able to solve hard problem is different type of frustration. Actually, Gupta, you are right. But what if I see a stupid problem or there's something wrong with tests? I don't know how often this happens in my problem solving streams or screencasts. It's quite rare. But when I see a stupid problem, then I might get frustrated. I missed the old comment by Gupta that I should just take a screenshot of the body of the email. First thing is I should have showed you, but also answering to their second email, I should have indeed give them the screenshot of the first email. Later, can you talk about code versus problem that you solved in a contest a few years ago? Some particular problem? I don't know, Onion, what you're asking about. Okay, results. Graph. Easily graph. Twice the votes. Then let's do graph. And unless it's very easy and I solve it in 1 minute, this will be the last problem of today. We see each other on Saturday, 2 days from now, just after Code Forces Rife round. I will talk about my solutions, just like a week ago. So, updating the link. Is there a vote, or will this video be uploaded on YouTube? Both. You can watch later on Twitch and you can watch later on YouTube. I need to work for CD Projekt Red in Poland. Do I need to? I'm not a game developer. But it would be awesome to help them with something, like to work for several hours for CD Projekt. I already thought a long time ago that I should send them an email. Hey, I'm very good at algorithms. If you have any issue, any problem you need to resolve, hit me up. I will help you for free for like 1 day. Just for bragging rights. So I could say, yeah, I worked for CD Projekt Red. I'm not going to switch my career just to work for them. Gaming industry is quite bad for employees because there is a big crunch, and basically it's often said that employers, they pay in dreams because, you know, you make your dreams happen, especially Blizzard. Okay, return the number of regions. Just like in problem about islands, like if you want to solve this problem, you need to first do Leetcode islands. This one. You're given a grid corresponding to water and land. You need to find the number of islands. And there are some follow-ups on this, including a very hard one about shapes of islands. It's something like you can rotate them, you can mirror them. Yeah, it's difficult. But here we'll try to do the same thing. And the same thing is, well, if you want to find a connected component where you can get from the first cell, you can use DFS or any other search like BFS, or something completely else to say what is connected to what, or to say what is in the same group. That's called DSU, disjoint set union, or find an union. Because it's a graph problem, I would guess that more people would first try DFS. And the time complexity is linear, so it's fine. Recursion hurts a little bit. Like, recursion is slow in computers than anything iterative, so DSU maybe would be faster, even though it has some additional logarithm in complexity. But let's go with DFS. in which there is a job command. So many people ask what I do for a living. Yeah, let's do DFS. And for example, starting from the top left cell, I can run DFS. I then need to understand to what neighboring cells I can get. And I mark them as visited. I'll keep doing DFS. Once it's done, no more cells to visit, I need to start from some other cell, unvisited yet. So this would be solution for problem islands if it wasn't complicated with, you know, diagonals. For every, just pseudocode, for every row, for every column, if not visited of row column, and then DFS of row column, and this will mark as visited this cell and everything in the same connected component. Answer plus plus, the number of regions plus plus. At the end, return count regions. But here, it might happen that, let's see what is the output, what is the input format. Each square consists of this or a blank space. Let me understand this one first. This is actually a square of size 2 by 2, where in top right we have this, in bottom right we have this. And now if we start from this, we should mark this cell visited, but this area is not yet visited. So actually this, we should mark in first DFS that this is visited and only this half of a cell. So maybe every cell should be split into two smaller cells, two smaller vertices in our graph, and I would only mark this as visited. But sometimes it will be like that. So it's not always top left and bottom right. And then maybe every cell should be treated as 4 vertices, because maybe it's like this, maybe like that. So imagine that there is vertex representing each triangle of a cell. And if there are no diagonals in this cell, then all of them are connected. But if there is this diagonal, then only those two are connected with each other, those two are connected with each other. So again, for input of size 2 by 2, imagine that there are separate triangles denoting parts of cells. And so on and so on. And if there are no additional segments, then say that there is an edge between neighbors, like that. Also there is like this. This is the graph. And just run DFS from every vertex if it's not visited yet, and so do whatever we would need to do to find the number of connected components in a graph. I will finish this beautiful drawing. I didn't, well, imagine triangles there as well, just I'm lazy to finish it. Why is it looking like a pizza? Because pizza also is split into triangles. Okay, now instead of just saying that everything is described by row and column, because in problem islands we just have row and column, I would also have here some type from 0 to 3, 0, 1, 2, or 3, and this type will denote, let's say that within a cell, this triangle is 0, then maybe 1, 2, and 3. We need to decide something. And then my logic will be row columns 1, so this, let's say 5, 5, 1, is connected to, in the next cell, this left guy. The left guy is 3. So there is edge, like that, between type 1 in one cell and type 3 in the neighboring cell. So this denotes an edge between row column comma 1 and row column plus 1 comma 3. Column plus 1 denotes the next cell on the right. And like that I need to figure out a lot of connections. Plus, within the same cell, 0 and 1 are connected unless there is this diagonal. 3 and 2 the same, 0, 3 are connected unless this, and that's it. I think it's possible to only do like the number of vertices I will have is size of the grid times 4. I think it's possible to do size of the grid times 2, but it's not better. I like my idea. So yeah, for every row, for every column, for every type, if not visited, then DFS from it. And I need to pass grid in order to know what are the diagonals within cells. Pass with reference, and also for safety with constant, just not to overwrite something by mistake. Okay, this. I will also need to pass visited, but I will fix that at the end. I like to make the main thing first and then fix the details. Okay, and now there are a few possibilities for what to do here. I guess I will do a lot of ifs. I don't really see a better way. Like if I am of type 1, then go to 3 in the next cell. DFS of row col plus 1, 3, and pass the grid. I see already that I will pass a grid so many times that while this is nice, and yeah, even during coding interview maybe you should do it like that, I'm lazy. I will just make it global. So for example, after getting this argument, let's overwrite, and now I can access global grid, and I don't need to pass it every time. I will do the same with visited, just because I'm lazy. You shouldn't really do it if you will be judged by quality of your code. Okay, here I should also do if column is smaller than width, or column plus 1 smaller than width, and not visited of that new cell, but this is so much code. Yeah, I need this, and I will have a lot of such ifs. So instead of doing all of this here, let's just do it at the beginning of DFS. If not inside the grid, or if already visited, then return. This way, in all those like 5 ifs, I don't need to every time check if I go to a valid state. Okay, let's 0 of me will be connected to 2 of cell above me. Rows are usually numbered from above, so row -1 is cell above me. I can write above me, on the right from me. If type is 2, then go to the bottom, and there will be 0 there. Below me, DFS of, and finally for 1, go to the right. Oh, something is wrong. Yeah, because I already had it. For 3, go to the left, and there will be 1 waiting for you. So row col -1 is on the left. We can take a quick look whether here I have 4 different types, because there are pairs, like 2 and 0 are connected. 3 and 1 are connected. If I make a single mistake here, it might be visible here that, oh, maybe 3 is repeated. That would be an obvious mistake. This, and we also want to mark something within a cell. Like from 0, I need to go to 1 and to 3 in the same cell, unless there is a diagonal. If grid of row call is not this character, this prevents us to go from 0 to 1 and 3 to. How to efficiently move between those? Instead of ifs, I will see a trick here. I will just XOR by 1. To get from 0, 1, or from 1, 0, XOR by 1. 2, 3, the same thing. This way I avoided some ifs. If grid of row column is different than this, maybe there is the same kind of trick here. If how to move between 0, 3 and 1, 2, unless there is, of course, such a forbidden diagonal. This happens to work. 0 and 1, 0 and 3, their XOR is 3. 2 and 1, their XOR is 3. If this wasn't true, then I would make a lot of ifs. You can also use switch for readability. Yeah, it's just that when I learned coding, I wasn't aware of switches, and then I never do them. But indeed, here, how to write it? Switch type, and here you can do something like case 0, then something. Yeah, that would be better. I usually, during like contest or something, just put else's here, which is not the nicest, and here else assert false, just in case I messed up. This is like additional check when I run for samples, that I maybe missed some case. Well, this seems better. It's more in order, 0, 1, 2, 3. But I agree with Omer that switch would be better, switch case. I think that's it. That's all the transitions we need. And what? This was pseudocode for problem about islands. I have plus the count of regions. And I need two things. I need function inside. Row must be between 0 and h minus 1, where h denotes height. I very much like to create a variable for height, instead of typing something like grid of 0 size or grid.size, because this is so the opposite of meaningful. You want your code to be readable. Like if h doesn't convince you, then just put height here. It's very easy to understand this. Like, it's perfect if your code is kind of self-commenting. If you look at line and you see what it does. Do this, and I still need to in some way create it. If I need that in multiple places, then I will make it global maybe. Okay, oh, visited. Visited. No, I need height and width. How to make it nicely. Let's do this at the beginning of our program. Height and width. Now visited. I don't know if, yeah, it can be not empty. So this size of size height by width. This creates a like two-dimensional array, like bool visited by height by width. Always put height first, because rows usually go first. If you do that in every problem, it will be easy for you and you will never mess it up. No, not never. If I said that, then for sure eventually I would make a mistake and somebody would point that out. You will rarely make mistakes this way. Oh, this is a special character in C++. This escape character, you need to put it twice. Visited. Oh, I need 3 dimensions. That's ugly, very ugly with vectors. But here you go. It's height by width by 4. And I wrote h instead of here. I think that width is better and height is better. It's just that because of competitive programming, I'm used to short variable names. I still prefer row and column instead of R and C. But H and W, I'm just used to putting uppercase letters. Yep. Accepted. 40 milliseconds, but don't worry about it on Leetcode. Just worry about your time complexity. And that being said, in graph of size n, DFS takes O of n time, n plus m. DFS is of n plus m, where it's number of vertices and edges. The number of vertices here is height times width, h times w, and the number of edges is, for every vertex there are only a few edges, so O of 1, constant number of them. So I can say that number of vertices and edges is of the same magnitude. Since someone used C++ sensors for 3D arrays, so they are not so ugly. Tensors. I don't know what that is, sorry. Isn't assign better than resize? I think it is. I did something that works. Yeah, assign would be better. What is this comment in the chat? I left coding because I can't code. I quit. Now I am an American football player and I play for Miami Dolphins. This is like some copy, like some story from the internet, copy pasted all over the place. Okay, we are 2 hours into the stream and I think this is a good moment to stop. I don't see questions about this problem. Hope you enjoyed it. Feedback is more than welcome on Discord. Join the Discord server. Yeah, homework and rate. Oh, what did I do? Join the Discord server. What does assert mean in C++? You can Google and read about it. So you never satisfied your dreams of becoming a football player then. Homework and rate. Yeah. Homework and rate. Let me think for a moment about this. Is this a good problem? Yeah, it is fine. I don't like circular subarray. This will be one homework problem. I wonder if I should choose it in advance. Any suggestions for the homework? And just like last week, I will give you 2 problems, and next week we will start with discussing those 2 problems. I think that this is more educational for you, rather just seeing me open a problem and start when I immediately start talking about it. The other thing is that if you want, I can give you time after opening a problem suggested during a stream. We can make like 5-minute timer, and only then I will start discussing it. Whatever makes the streams most educational. Why don't you get a job at Google or other fun companies? You can read my FAQ and you will learn the answer. Even odd tree sounds interesting, but were you the one who suggested it earlier? Merge two sorted arrays in log n. That's impossible. It's possible in linear time, not in logarithmic time. Just pick a problem with high acceptance rate. Why? Rife is Raiffeisenbank. Interesting. Is that already announced? Yeah, it is Raiffeisenbank. Thermos. I have 2 Thermos Max already from Yandex. So no thank you. I have a lot of t-shirts. Bluetooth speaker, no. Bambag. What is Bambag? I have like 5 power banks from different competitions. I have like 3 Bluetooth speakers, and I already gave some away. I have 2 Thermos Max. I have multiple contest t-shirts. So the only maybe interesting... Oh, is this Bambag? It's Nerka in Polish. Yeah. No, not my style. Well, I can always get 51st place. Oh no, random participants. So just 21st place will be fine. Will I participate in Yandex Cup? Yeah, I will, if I have time on that day. Win and make us giveaway. How is it called? Shipping cost will exceed the cost of this product. High acceptance rate, design this. What about a very easy problem? The stream will end in 1-2 minutes. Why is this such a stupid problem? I mean, can this be done if big car can fit into medium plus small slot? Yeah, okay. Let's say that this will be one homework problem, but we'll talk about other possibilities as well. Like what happens if medium can take 2 small spots, or big can take medium plus small. So basically assume that this is of size 1, 2, and 3, the slots. That should be more interesting. I think it's possible as well. So, yep, homework, and this will be in YouTube description and in Discord as well. On Saturday I do Code Forces solutions just after Code Forces round, so see you then. And thank you all for watching the stream. If there is somebody doing coding interviews, I will host, otherwise I will not. More than 100 viewers today, nice. We have our Soner Gonu, the coding game guy. But I think the idea of rates is that it's about discovering new interesting channels. I very much enjoyed the stream by a guy who made guns in 3D and gave it to some huge cactus. I liked it a lot. And also the guy who made the co-op game to move in 4 directions. The rates should be about that. I don't hear anything. Now I will hear if he says anything. Leetcode, interview. If he says anything, I'm reading him. If not, then not. I think that streams must be with some commentary. The cactus shooter guy? Yeah, the cactus shooter guy was amazing. Do we have the gun guy? What was his nickname? Sorry, I don't remember. And he wasn't a regular Twitch streamer. He just did some project for uni. The cactus shooter guy was amazing. Yingushi? What? I don't. It's in science and technology. Even if this is the same guy. Yeah, that's not. Okay, I think no rates today because I just don't see anybody particular. Oh, maybe this. Okay, then one of those two. Whoever says something. We can't live without a rate. You're forced to spend time in front of your computer. Okay, here we go. Look at some drawing of a graph. I wonder what this is. Edge, wait. Union, I think he's doing MST. Yeah, he's doing MST. What's the probability that he will notice the rate though? Okay, I'm raiding. And go watch him. You can help him with MST if he struggles. See you everybody. Thank you for watching.